Yeah? Good to go? Okay. Hey guys. Today we're going to talk about traits of maintainable architecture, and I will try to focus on practical advice, not the stuff you can read in design pattern books. I will mention design pattern, but more like an overview of some of the favorite ones I have. And I will also look at the two most popular UI patterns in iOS and what's missing with both of them. And I'm an iOS consultant. I'm currently leading development at the New York Times. And as a consultant, I get hired to work with different companies. And a lot of the times, the things I do for the companies is the whole project review. So I join a team. I get all the source code. I review the whole architecture. And I try to figure out ways to improve it for the team, and not only improve the architecture, but also improve the process of development and how they work together. And so I get to look at a lot of projects and see a lot of the same problems over and over again. And I also do a lot of open source, and my open source is powering up like more than 50,000 applications right now, including sorcery and playgrounds and lifetime tracker, all this stuff. So the last 10 years I spent working on those tools and libraries that basically affect how we do daily development, how we do architecture, and the common problems we have in iOS. So how important is good architecture? Can we just start coding when we get a new project without actually spending time to design it? And now this is something that the perspective you're starting with will make a big difference, because if you work for a product company, your experience will be very different than if you work for a software agency. And the reason for that is actually working both, by the way, so I know how it is. But in software agency, you often get hired to do the first version of the application. So like you're doing the MVP for like a new startup or a new company or a company that just wants to get into mobile and they have their product on web. And so usually what happens in most cases is you get hired to do the 1.0 version, and if it's successful, the companies usually get it back in-house, they build out their own team and they take over. The problem with that is, if that happens, you don't actually validate your architecture choices. So if you only do the first version of the application and then it's out of your hands, you don't see if the things you decided to do will actually be flexible in the long term. Whether it will be, stand the test of time, whether it be flexible for the changes that always happen. And so this is a little problematic, and it's a little different in product, because if you're making your own app, or you're making money out of that app, and you have to maintain it for the next 5-6 years or so, then you will feel your mistakes very much, right? If you made a bad design architecture choice at the beginning, and then requirements will always change. I have never worked on a project that was designed up front, and then that's what we deliver. Every time there will be pretty significant requirements changes as you develop. So if the architecture is a mess, what happens is you have a really hard time doing those changes because you didn't anticipate for it, right? So in my opinion, it's extremely important, whether it's a software agency or it's a product company, because if it's software agency, even if the first version works and they take it in and then someone else sees your code, there's your name on it usually. People usually sign the files with the code. And then if it's a mess and it's a very problematic to edit, they will remember. You don't want some psycho to have your name and know where you live. So you wouldn't want to leave a bad impression as well. So I think it's very important to think about this up front. So what are some of the traits of good architecture? You want dependencies that are isolated and they're easy to change. You want objects to have clear boundaries to understand what they do. You want to be able to follow the data flow with ease. You don't want, when there's a bug or something like that, you don't want to first have to figure out where does it start, where does the flow of the information start. You need to understand that very quickly. And you want to be able to test those things, both in manual testing, when you have to click through everything, or in the automatic testing, preferably. And it has to be flexible, because the change will always happen. Like I said before, I don't know if anyone ever had a project that didn't change for me, maybe I am not lucky with clients, but they always change their mind, and it's, sometimes you have to implement something to see that it doesn't work, and you have to change the approach, even from the UX perspective. So you have to make it flexible, but now there's this fine line when you over-abstract everything, and you add a bunch of protocols, a bunch of abstractions to make it flexible, but what it does instead, it makes it complicated, and it makes it hard to change. And you want to have a good developer experience because no one wants to feel like shit when they do their job, right? You want to enjoy what you're doing, especially since our job is actually fun to do when it works. So why do you want limited dependencies? Remember Parse? Parse was acquired by Facebook. It was very, very good tool as an idea. The SDK was so-so. I actually used Parse in Foldify, which is one of the apps I had on App Store, and it helped me develop the application much faster than I would do otherwise, because I'm not a backend developer, I'm not very good with the, I know some Ruby, but I'm not very good with making APIs on the servers. And so the problem with Parse was also that when they started, their SDK would not start in production. So if you try to use their SDK fully, like to download images from their servers, it would literally crash your application, which was totally, ridiculous. And so you want to build a small layer always between those dependencies so you can actually avoid it. So for Foldify, I use their SDK to get the object data, but then I would download images myself to avoid the rasters, which should not be needed, but small layer allows you to do that. Separation of concern, clear boundaries, objects should be responsible for one thing, unless it's something that coordinates different objects. So if you use composition, that would be the case. And the reason you want to have this is you want to look at a class in your project and you want to understand what it does. If the class has 2,000 lines of code, you probably won't be able to do that. You won't be able to just open it, look at it quickly, and understand the main principle. You don't need to understand every implementation detail, but you want to understand the role. And the more a single object tries to do, the more potential for bugs there is, the more permutations of state there is, so it's harder to test. And this is never good, so we want to avoid that. And testability, like TDD can help you create better architecture. And this is like one of the biggest things, because when you're writing tests first, before the API of your project exists, it actually forces you to think about how the API will look from the call side perspective. So, when you back in object, you see you had the headers and then you had the implementations. And so you often wrote the header first to have the name of the method and the arguments. In TDD, what happens is that would not even exist. You would start in the test file, in the test specification. You would write how you would want to call a method on the call side. So you would create an object, and then you would start writing how it's supposed to be called, and that makes it far better, because when you understand it from the call side perspective, it's not in a void that you design it, it's more on the specific use case, and that makes it just much more efficient to make a nicer API, so you have to spend less time refactoring all those things. And the thing with TDD is, if tests are hard to write, if you are having real trouble writing a test for something, that is usually a sign that something in your architecture is wrong. So for example, things that make testing hard is if you use singletons, because you cannot really replace singleton for tests, right? If you use just a global shared object, you cannot mock it. So this is a problem. And tests, when you write tests, you see that problem immediately because it just makes it harder. And testing is much more popular now in iOS community than it used to be, but it's still nowhere near how popular it is in web technologies. If you ever work with Ruby or other backend services like Python, tests are always the first thing people write, because that's the way it works. That's just the pattern that everyone follows. And I feel like a lot of people use different arguments for why they cannot do testing. Like for example, a small team, you don't have resources, and then it takes time to write tests. But I think that the smaller the team, the bigger the benefit. Because if I work in a big company, an enterprise company, I usually have QA people to do the manual testing for me. I don't actually have to do it. because they are the one responsible for making sure that the app version works when we change the code. If I work in a small company, I have to make sure that I can screw up the product, right? Like if I do like I'm the only developer on Foldify, and I have a couple million of users, so when I change something and I don't have tests, I have to make sure I didn't break anything. Because if I release that, then a couple of million of users will have a broken application, I will lose a lot of money. When I have QA team, they can do it for me. So the smaller the team, the bigger the return of investment for each test that I have, because it just protects my ass, basically. And that gives you the confidence to change the working implementation. Because if you have the regression tests, now you can go to your product and, well, this class doesn't look as good as it's supposed to because we got this different change requests. I actually would like to refactor it. And now, if you don't have tests and you want to refactor something that is in the core of your application, let's say you want to refactor like the core parsing in your app that affects all the model objects you have. If you refactor that without the tests, now imagine a bug there. A bug there would affect everything, right? Because it's reused for different parts of the model objects. And so this is very stressful. It's not, it's not something you want to do without having enough, time to test everything out. And usually you work under time pressure, so that might not happen. Whereas when you have tests and you have like very high test coverage, that gives you confidence. Like, okay, I can change it. I run tests. All the tests are still green. So all the top requirements for this are still correct. So everything else that uses it should still work. And this is the biggest benefit that you get from testing. And this is the thing that the most people ever say for me when I try to suggest testing. So how do you convince your clients? Well, I don't think you should convince your clients. If you're a freelancer and you get hired to implement an application, you estimate for the client how much time will it take, right? When I hire builders to build my house, I don't tell them how to do it, right? I don't tell them all the intricate details. I tell them how I want it to look. I want this product to work. And so when I get hired to do an app, they tell me, okay, I want this app to look like this, to have this and this functionality. They don't care if I use NVM, MVC, or whatever else if I'm hired to do the whole app. So when I estimate the amount of time and money that they will have to pay, I estimate with tests in mind. And the thing is, if you get used to writing tests, it actually makes you faster. It can actually make you much more efficient as a developer. Because oftentimes you have to wait for other people when you're developing an app. So for example, you have to wait for the API from the server to be implemented. You have to wait for some, the API is usually the most limiting factor because, we design so you can just use wireframes. And people, when I work with different consultants over the years, people would always say like, oh, I'm blocked, I cannot work. Because there's no API. And this is just ridiculous because if you use tests, you can just stop the data and you can implement all of your functionality against the contract that you agreed on because you usually know what the format will be, right? You should be part of the process for that. And so when you have an agreed contract, you can just implement the fake data, implement the stuffs in tests, and then implement your part of the application. And when the API is finished, you just verify that they follow the contract. And you can verify that by switching from stuff to real data and running the test again. So it actually makes you faster, which is awesome, because being blocked is just something that should not happen for most of the work we do. So what are some simple signs of app architecture issues? So like if you run this command and you see something like this, it's not good. Because if a file has thousands of lines of code, that usually means that it's breaking the single responsibility principle. And that also means when you go to that file, you have no idea what it's doing, unless you read a lot of code. And even then, you probably don't know what it's doing, because it's doing everything. So you want to avoid that. The other thing that I often look for as apps is using global shared state objects. So for example, a lot of people like to use shared application. Now it's just shared in the newer Swift, right? And AppDelegate is not a dependency injection container. It should not be used for this. It should not be used to store singletons. or object configuration. And usually when that happens, you can look at the dependency visualization, and then you can see like this thing up on the top, it's an app delegate, and everything connects to that delegate. It's like the source of your application. At this point, you can just write everything in main.swift. And like when you look at the dependency visualizer, the benefits here is that you can see things that are connected, and so those things are potential things that can be extracted to separate frameworks. So this is a good thing to start when you try to refactor your application. So design patterns, I mentioned a few just by name. But the thing with design patterns is people get very religious about it. So when they make a decision to follow a specific design pattern, they will follow it to the death. And it's not very pragmatic. And oftentimes, you know, each pattern was created to solve a specific problem. And you have to know a lot of them to understand that just because you chose to use this architecture doesn't mean you have to use it everywhere, because there are situations where it makes no sense and it just makes things more complicated. And so you can still use design patterns. So just because you know the Gaggle for book by memory doesn't mean that you're actually doing things right. So for example, singletons are not inherently bad. And the problem with singletons is people don't understand what singletons are, because they are not meant to be a global state sync. It's a pattern to deal with resource contention. So if you have something that cannot exist in two instances, for example, older database, you couldn't have two writers, right, to a database. You can only have one at the same time. So that's where singletons comes in. And it's not, a lot of people just use singletons just to have easy access to the object, not because it cannot exist in two instances. That's what happens for most people. So for example, how can you work around it? Like a good example of a singleton would be a logger. In most apps, you usually have a single logger that you use to, every part of the application at some point needs some kind of logging, and you don't want to use prints. I'll show you in a second how to replace that, but referring to global state variable is easy. So when people use loggers or they use image providers, they just want to do logger.log and they'll log the message, right? It's easy, it's convenient. And people usually do it because the architecture is complicated, so getting that instance of a logger into your view is hard, because you would have to get it through the view controller, inject it into view controller, then inject it into view, or maybe even, you have a even harder hierarchy because there are multiple view controllers that are presented one after another, and then you have to inject everything. Very problematic. But let's say you want to do the logging still. And even if you have a singleton, what you can use, for example, is like a protocol composition, protocol-oriented programming, and then you create this protocol called loggable. I have an article in my blog that goes into detail how this is implemented. But the thing is, you can just conform to a protocol and get access to the function. The function underneath can reference the singleton, but this has a benefit because it uses singleton as a default implementation, which means that in test, you can actually override it and provide your own implementation, and you could even test that logs are actually happening, which is convenient. That's one of the simple things you can do. And this also gives you introspection, because it's an extension of a type, you can get information about the type itself. When you log, so you don't actually have to specify it. Whereas when it was a shared object, like a global, you will get this information. So you couldn't just log the information about the object itself without having to specify it by hand. So this is better for many reasons. Composition is by far the most favorite pattern I use in my toolbox. And it's mostly because this pattern naturally leads to other patterns like single responsibility principle and dependency injection. It's all connected. And Swift leverages value types, which means you cannot really do inheritance for them. You cannot inherit structures, so you have to compose them, which goes very well with this. And because composition leads to do not repeat yourself and SRP, which is single responsibility principle, it means the objects that you create and compose are very small. Small objects means smaller public API, and smaller public API means less permutations and less things to test. Because if you have a function that has 10 arguments, the amount of permutations that can happen for those arguments is crazy. If you have a function that has 2 arguments, it's much simpler. So you want to keep the public interface simple, and composition makes that easy. And it also makes it flexible and easy to rearrange, because if everything just does one single role, then you can change the implementation of that role. And you, for example, you have like a persistent coordinator in your application, which is the only role that is to save the core data, but you can also have other implementation that it saves the memory. And then everything else that deals with objects doesn't have to change. You just change this one small object, and now you have a different data store. So this, this is very, very useful. And it's far better than inheritance. And if you don't trust me, look at how games are made. I used to work in game dev, and Unity is very well-known game engine right now. And it's using something called entity systems. It's basically what all AAA level game engines are using. Entity systems are composition pushed to maximum. The way it works is a game object in Unity contains very little information. It has no logic. It basically contains in Unity, I think it's just a transform, which is just a position 3D word. And then it can have other components. And a component is like a behavior, functions. So for example, when you make a game in Unity, you have a game object, everything is a game object. But then you can add physics component to each of the game objects you want. You can add a geometry component to each of the objects. You can add a script component that runs some logic. And you compose your objects like that, and that is extremely flexible. Because not only is that not hard-coded, it's not hard-coded that your enemy in the game has this specific functionality, which is, if you have let's say you have a component that's responsible for walking, like for following the player. So you have a player in the game, you have an enemy. And then you have a component for the enemy that is following the player. That's the only responsibility that the component does. And now, if a designer decides that the enemy is too hard to kill, and it's following the user, so that makes it harder because you cannot really escape, you can just disable that component, and the enemy will still shoot at the player, but it will not follow it. So it's just a configuration. And this is extremely flexible. If you look at the games that Unity made, there's like a gallery on the Unity website. You can see different games that are made with it. You have games ranging from like AAA level games, like millions of dollars, to a completely indie 2D games. And this, this is like a proof of how flexible the architecture is. And all the other game engines, as far as I know, the big game engines use entity systems as well. Like Unreal uses that. And this is really just because it's proven. It's been proven for I did game dev more than 12 years ago, and that was still the best solution back then. So far, there's nothing that beats composition. And if you use composition, you have to use dependency injection, because it just happens. You have to inject those things, you have to configure it. And dependency injection basically allows you to swap different components for their replacements when testing or for different platform. And even Apple recommends this. But the way they do it is very bad, which I'm gonna get back to. I got very angry when they showed it at WWDC because, very angry. Let's sort of look at the MVC and the MVVM first though. So those are the two most popular architecture patterns, how people call it in our community, but this is not an architecture pattern, this is a UI architecture pattern, which there is a significant difference because this doesn't tell you how to do data processing, doesn't tell you how to do all those things that are way more complex than doing a freaking UI, right? This is how you compose your UI layer. This is not how you compose your whole application. And even with this, people disagree and make stupid mistakes. Partially because the way the classical MVC is structured is different from what we had on iOS. So this is how MVC was supposed to work and how it can work in a more functional environment. Where the view is down, it's rendered by the controller when the model changes. This is almost impossible to apply on iOS because how iOS UI kit is structured. So what Apple says, you can see already the difference. Like this is what Apple says that MVC is, and controller is the mediator between the view and the model, and the controller obviously will be their least reusable part because it has too much knowledge about the other parts, so you cannot really reuse it. But that's still not how it works on iOS. Because view controller on iOS is very tightly coupled with a view, because the lifecycle events are creating this problem. So now you have this thing that makes the view controller almost not, well, it doesn't make it reusable for most implementations I have seen. And this is still a pure excuse to make massive view controllers, because you can still compose view controllers together. But this is how people do MVC most of the time on iOS. And you know, I actually seen a lot of projects that did MVC right, and the thing about that is, it's the same as in the view model. You have to treat the view controller as part of the view layer. It's not actually controlling stuff, it's actually view. Because that's the only way when you treat it that makes sense, and then the composition makes sense to create smaller view controllers. And like a lot of people would create a view controller for a single screen. It always has to be a single view controller, whereas in fact what you can do is you can compose a single screen out of 10 different view controllers. And then those view controllers can be reusable. They are still tightly coupled to specific models and data that they represent, but at least you can reuse it if you have the same data displayed somewhere else. And I worked on many applications that had this. And people use MVC as an excuse to write bad code, because, you know, I have MVC, well, I cannot do anything about it, so I can just, you know, add another 500 lines to this file and it will be okay. It's not okay. There are ways to do it other than composition. For example, there's this pattern I promoted a while ago called behaviors that allows you to, basically it's composition, but it's done a little different. It allows you to connect logic visually even, like even from interface builder, you can connect stuff. So for example, if you have like a tweet composer, you can just set a behavior for limiting the amount of text you have in the text field in the interface builder. So you can create an object and tell that the type of the object is text field limiting whatever behavior, and then you can connect it to the text field, and you can say that the max amount of characters you can enter is 280. And that doesn't even require code in the view controller itself, so you can have like a small objects connected very easily. But the thing with MVC that I don't like, and even the talks that we see, like Dave DeLong has a talk about MVC, so that's really good. And he also says that you have to treat view controller as a view layer object. But the problem with that, and every proponent of MVC I have ever talked to just, you know, doesn't care in most situations, is that you cannot really test well if you have view controllers because of the lifecycle events. Simulating all those things is complex, and it doesn't allow you to very easily, you know, 3D UI is slow, it's expensive, it's error prone. So if you care about TDD, MVC is not a very good choice because of this problem. So how does MVVM differ? So in MVVM, if you do it correctly, both UI and UI controllers are considered the view layer. There's no tight coupling between the view and the model, and this usually requires some kind of binding library. It doesn't require FRP. You don't need to use Eric Swift or Reactive Swift to do MVVM. I would even recommend not to do it because you can implement observable in 100 lines of code and it will suffice for binding, or you can use keypads now, which are extremely powerful, and it will be a better choice if you don't like, unless you know FRP very well. But FRP itself is extremely hard to learn. There's a very steep learning curve. And most people, if someone says FRP is easy, it usually means that they don't know it very well, because it's easy to start and you can understand some of the signal processing. But when you get into like advanced use cases, it can get very complicated very fast. And the other thing with FRP is, if the whole application is based on signals, you can have a signal wreak havoc everywhere. I actually worked on a project that used beacons and used signals in beacons. So when there was a beacon recognized, everything in the sample would fire up. And then good luck at figuring out what's wrong, because there was a lot of things wrong. It took me 16 hours to change 2 lines of code. And those 2 lines fixed things that were broken for 2 months. which is awesome, but it's also extremely stressful to work on. So you have to be careful with that. So both of those patterns, can be used to create good and maintainable UI architecture, but there's one thing missing in both of them. And the thing missing is, how do you actually go from one screen to another? Because this just describes one screen. I don't really work on apps that have a single screen. It's usually a lot of different screens, so how do we manage it? And both of them lack the router and dependency injection for the router, which is required. And so there are a couple of different solutions to this. Like, there's Viper, which is extremely specific of how you should do architecture, which I am not a fan of because I feel it's over-engineering for 90% of applications. The fact that if you search for Viper, you'll find 2 different code generators on GitHub just to generate the empty files says a lot. And Apple talked about using dependency injection at the WWDC, but their example was pretty terrible. And I have described how they do it. So let's see. Let's say each circle will be a view controller, each letter will be a dependency. So we start our application with a single view controller that has a single dependency, which is called A for simplicity. Then we have to create another view controller from that, which requires a different dependency, which is called B. Now the problem with that is how I will recommend injection is that the first view controller injects it into the second view controller, which means that the first view controller now has both A and B, when it doesn't actually need B. It doesn't care about B, right? It doesn't use it. This gets elevated very fast. So you end up with something like this, where the first view controller has all the dependencies, and then each of the view controllers until leaves have multiple dependencies that they don't care. And if you look at this, it basically means that the first view controller or view model becomes a state sink for all the remaining ones. And also the other problem with this is when you read the code for this, how do you know which dependency do you really need for the view controller or the view model? Doesn't matter if it's MVC or MVVM here. Another problem is I want to test this, right? I want to test this, and now I have to mock all of those dependencies, even though if it uses only a single one. Big problem. So, and also obviously each view controller has to know about another one. So the next one in the chain, you have to know that. So you cannot reuse it, or you have to have a bunch of fixed statements, because let's say that this is the situation when it's an iPhone and iPad, you present different view controllers. And now you have to have each statement to decide which one to show, which is just terrible. And you can end up with a code like this, which is still very simple code, I see way worse. So, a button on stack, you have to create a view controller, then if it's on iPad, you have to push it, when it's on, well, actually it should be reverse. If it's on an iPhone, you have to push it, when it's on iPad, you have to present in a popover. It's not good, it gets way worse. So lack of router leads to unnecessary dependencies.